The unmarked one? Okay. Very good. Well, thank you very much. As Paula said, I'm from EPCOR Utilities. We run water, wastewater, gas, and electric utilities in municipalities across Canada and in the southern United States. Myself, I'm the manager of asset performance management for the electric distribution utility in Edmonton, Alberta. So you can see some of the numbers on the screen there. That's a city of 1 million people, and a city that large, a power distribution company will have about 200,000 assets evenly distributed around the city, so poles, cable, transformers. Now, back in 2004, we implemented those assets in Bentley's AssetWise product in a pretty traditional enterprise asset management asset hierarchy. So there's nothing particularly unique there. But what's unique is what I'm going to talk about today is a project we conducted to analyze that data, developing statistical-based failure curves for our assets, an asset health index, and risk-based lifecycle replacement program. So why would a utility do this? What's the advantage? Oh, did the power go out? Don't you hate it when the power goes out? You lose what you're working on, your production system goes down. It's a real cost to society. So in power distribution, we have a lot of different assets. It presents about 30% of our failure causes from defective equipment. It's a range of things from oil leaks to rusting transformers. And some of our assets fail quite catastrophically, causing collateral damage. And what we mean by that is they might destroy other assets, or there might be damage to public property or private property, or even to staff or the public, injuries. So our wake-up call came in 2014. So this graph is showing you our system average interruption duration index. So the numbers on the side there represent the average hours of interruption for a customer in a year. The purple line across the top is our regulated threshold. So just over an hour per customer per year is where we're allowed under regulation. If we cross that threshold, there are substantial financial penalties. And if we're really bad at it, we can even lose our license to operate. So it's mission critical. In 2014, we came perilously close to hitting that threshold. So that drew a lot of attention to this. And we did a little bit of analysis, and that's the red line here. We could see that we'd been on an upward trend for the last 20 years. And that's because of the aging of the underlying asset population. In Edmonton, there was a lot of growth in the late 70s and early 80s with the oil boom from a generation ago. And those assets are now 35 years old. So they're reaching their end of life. And what made it worse is we had some corners of the city that were suffering more than others. In this particular area here, Kennedale, they were suffering what we call a cascading failure. So their infrastructure was largely 35 years old. And when we have a power outage in the power distribution business, we always isolate that outage and we shift load to all the other 35-year-old infrastructure, which stresses that infrastructure out and makes it brittle. And what we were finding is that the size, duration, and frequency of outages were growing with each outage. We had some customers that had 10 to 20 times the average number of outages than the rest of the city. So they were calling the mayor and the regulator and the newspapers. So we started up a project that looked at prioritizing asset lifecycle replacement to maximize reliability, at least within those targets that the regulator had set out, and also within the capital dollars we had available. So going on at this time, too, is the introduction of new performance-based rates. So effectively, our dollars were going to be capped. No longer could we just plow in another $30 million in cable. We didn't have that available to us. So we had to be more selective with the money we did have. Now, this is 2015 we're starting this up, so ISO 55000 had come out, so we're quite aware of risk-based asset management approaches, and we made that a requirement in the project. So risk-based asset management approach means looking at the probability of your assets failing times the impact of their failure, and using that to rank your assets for replacement. Now, we also did an asset condition assessment. Oops. How do we go back? Oh, there we go, I got it, thank you. We also did an asset condition assessment, which resulted in an asset health score for each of our assets. And we're able to use that health score to more precisely predict the probability of individual assets failing on those failure curves. So we worked with our data from 2004, that initial AssetWise implementation. So we had a good 10 years of work order history. It was integrated to Oracle Financials, so we knew the cost of repair and maintenance and replacement. We had a condition-based maintenance program, so we had a lot of inspection data of the assets over the time. And then in 2013, we integrated to our GIS system, so we brought in some more of our civil assets. And we also integrated to our SCADA control system. So this is largely an operations technology conference. So it's important to note that for power distribution, historical loading of your electrical assets is one of your primary indicators of the remaining life of your assets. So we took all that data out and analyzed it, largely in Excel, and created what we call an asset risk framework. So we analyzed a good 10 years worth of data, over 117,000 assets. Some of those assets failed in that time, some of those assets were new in that time, but it was enough such that we were able to develop failure curves for 6 of our major asset classes. We also had over 1 million records and inspection data, which we were able to use to develop a health index by looking at the indicators that were indicative of imminent asset failure. We could come up with weighted scoring system across those indicators for the health index out of 100%. So for example, if you had a pole that was 40 years old, but it had a fair amount of rot, maybe there was some woodpecker damage, then we would say that that condition was less than 100%. It was a poor condition. And we would use the health index score to age up that asset. So instead of being a 40-year-old pole, we might consider it to be effectively a 60-year-old pole, and it would inherit the appropriate probability of failure. So after all that statistical analysis, developing the weighting factors, we were able to come up with formulas which we actually implemented in the Bentley product using the standard functionality. This is a screenshot of an assets dashboard, its health dashboard. The rainbow graph in the middle represents its health score. The dot on the left side was an earlier health calculation, so the asset was in fair condition, it was in the yellow band. But the new indicators came in, and then at the next health calculation, the asset was deemed to be in poor condition and entered into the orange band. So we run this for each of our assets quarterly. Sometimes we'll roll up that asset data into our GIS system so we can map it out and look for clusters, look for trends in various areas. You can see red at the top of the screen here. This is pole data. So that particular neighborhood is an older neighborhood, kind of just after the Second World War kind of neighborhood. So those poles are getting pretty old, right? And we're starting to replace those. We'll also aggregate that data up to the asset class level so we can get an overall sense of the health of the system for management reporting. And we can see here that we have 8,000 poles of the 50,000 that are in poor condition. So now we have a program planned out to replace those poles. So that's the, if you will, the left-hand side of the calculation, the probability side of the calculation. The other side is the reliability or the impact side of the calculation. So basically what you're working towards here is an economic model to help you make the decisions as to which investments you should be making, which assets should you replace relative to other investment opportunities. So it's important to monetize those impacts. So we have our 4 major categories here. First, financial is pretty straightforward. That's the cost of actually replacing the asset. So we had, again, lots of history from our Bentley system where we could draw on for replacement costs. And in there, we also have the current equipment costs, material costs, labor costs. So that was quite easy to do. The next one, reliability, was an opportunity for some innovation here. So we looked at our GIS system, which is the map drawing you see on the right there. That's basically in power distribution, that's our digital twin. What we have is an electrically connected model. So we could see for each asset what the implication would be if that asset failed. How many customers would be affected? Are they commercial, industrial? And there's various techniques in our industry to monetize that, to create what we call a customer interruption cost. It's not so much money we save, but it expresses it as a value to society. The other two are environment and collateral damage. For that, we looked at claims history, we looked at various environmental fines or penalties, whether we've received them or not. Maybe they've been issued in the industry or they're just available on the books. And we use that to monetize those categories. So bringing that all together, you literally take that reliability, that probability curve, and you multiply it by the impact, and you create what's called a risk cost curve. So think of this. If your impact costs for losing a particular asset was $100,000, and at 20 years out, there's a 20% probability of failure, then you would literally look at that as a $20,000 risk cost at that time. So you combine that with the cost of replacing an asset, and it's basically an MPV for the new asset. You bring the two together, and you get what's called a life cost curve. And the inflection point of the bottom there we go, is your optimal intervention time. So that's the time in which the risk cost of carrying this potentially wonky asset is starting to outweigh any residual value of that asset. So this is that tipping point where is this asset worth keeping? So the raw numbers would suggest no. Once you're past that point, it's time to consider replacement of that asset. So we run this analysis for every one of the assets in the program, about 70,000 assets right now. And we generate a cost-benefit analysis for each asset, where the benefit is if you were to replace that asset or mitigate the risk, what the reduction in the risk cost would be. We also get years to intervention. So you can imagine if you had a 20-year asset and you were looking at this curve and your optimal intervention time was around 35 years of age, you'd know you have 15 years left of decent life in this asset. So it's not important to replace that asset right now. It's not economical. Some assets, of course, are deemed run to fail. So that map I was showing you earlier is actually a residential neighborhood. And transformers in that neighborhood only have 10 to 15 customers on them, and we can replace one of those transformers in a couple hours. So it's not a big risk to the organization. So most of those assets will be deemed run to failure in this model. But there's other assets that if they fail, you could have thousands of customers out for 8, 10, 12 hours maybe. So those kinds of assets would be ranked quite a bit higher in terms of risk. So all these numbers come together and give you a prioritized list of assets for life cycle replacement within the various classes. So literally pole number 1 to pole number 50,001, ranked in order of replacement. So our asset managers will use those lists to create their long-term plans, their 10-year plans. And then on an annual basis, they'll pull out specific assets, specific scopes of assets for work to be transferred to engineering and eventually to the field for replacement. So this is an actual screenshot from our asset risk framework. Now, right now, we're just doing this in Excel. Got to give my compliments to the programmers. They've done a pretty good job with the visualization here. But this slide is really about shareholder value. So as a utility, we understand our role in the community. And it's important for a stable electric system and competitive rates in terms of economic development for our community. Project outcomes. One particular interesting outcome for me, one surprise, was how effective we were at being able to systematically include the environmental and public safety factors. Going into this, I hadn't thought it was possible. Our consultant that worked with us, Metzco Energy Solutions, have a pretty good technique for monetizing those values and including it in the whole ranking system of our assets. We're even able to include higher scores for assets in environmentally sensitive areas. So much to the point that we're confident that we'll be able to mitigate these assets before there's any real contamination in the environment. Another thing that we've done here, because we're following a fairly rigorous process, we're getting working on our plans 18 months in advance. So we're getting these scopes of work out to our engineering teams and our supply chain management teams so they can make better labor and materials planning decisions, which helps with costs. Whoops. We're also, for the asset health information, the asset health index, we're better communicating the actual condition and status of our assets and better understanding that across the organization. But most importantly, we're improving our overall system reliability. Despite our aging asset population, we've been able to improve our reliability due to defective equipment by 43% in just the first 2 years of implementing this program. So looking at reliability overall, looking back at that SAIDI chart, you can remember in 2014 we nearly drove into the ditch. We've been able to bend that upward trend and leveled it out. So we've had a 15% improvement in overall system reliability since 2014 there. And though our 2019 numbers aren't official yet, I can tell you that they're even better than 2018. Now, the cautionary tale is, with a risk-based asset management approach, when you first implement, it's easy to get quick wins because the bad actors sort of stick out in the data, and you can focus on those. We still have this tide of aging population of assets coming in, so it'll still be a challenge to maintain reliability. So coming to the last slide here. So lessons learned, takeaways. Number one is make sure you continue to do your failure mode effects analysis and your failure tracking to implement these things in your enterprise asset management system. It's important that you have normalized data so that you can do your statistical analysis. We thought we'd done a pretty good job on this, but we still found it pretty hard to tease out a lot of that data from comments and textual fields where it was all buried away. Also, get to know your data and be prepared to modify it over time. So I mentioned that inspection data over 10 years, as managers changed, as inspectors changed, there's different interpretations of what indicators meant and how states were used. So when we were programming this in the Bentley software, we had to be very careful in our programming to make sure we understood the context, the period context, the time context of those indicators. And also, as you move forward, you're going to have new assets coming into your system, new tools, new inspection techniques you'll have to account for and be prepared to continue to program for. Make sure you align your impact assessment with your enterprise risk management system. So a lot of you are from large companies. You'll have some sort of enterprise risk management matrices or system. Here's ours: health, safety, environment, regulatory. We aligned our impact categories to those so that when we come forward with a cable replacement program or a cable risk, so we identified something like $3 million in cable risk, we could have that conversation with our executive and put it in perspective of other projects. And my last point, and probably the most important, is that if an asset is deemed to be risky, yet your health index score says it's in good condition, perhaps replacing asset isn't the solution. You have alternatives. You should look at reconfiguring your system. You might just have too much dependency on that one asset. And in the power distribution business, being a network, we have a lot of options available to us through switching or through running in new cable or new aerial lines. We can often reduce the risk on any one asset. So my biggest takeaway for you here is when you implement a risk-based asset management system, asset replacement is no longer your only option. So thank you very much.